In today's lecture, I am going to continue the structure of molecules. Today, I will explain you the concepts that explain the molecular bonding. The first concept is the valence concept and the second concept is the orbital concept. The first concept is the valence concept. It was proposed by G.N. Lewis and W. Cosell. According to this concept, in chemical bond formation, atoms take part by losing, gaining or sharing of electrons so as to attain a noble gas electronic configuration. We have already discussed this definition in the previous lecture with example of NaCl where sodium lost 1 electron and chlorine gained that 1 electron. If you have not watched my previous lecture, then link is in the description below. First watch that video and then understand the valence concept. Here we say that 2 or 8 outer electrons are considered to be stable. When an atom or molecule will have 2 or 8 electrons in its valence shell, it will be considered stable. Now we have two theories. Octet theory, also known as octet rule, rule of 8 and duplet rule. What does this theory tell us? The tendency of atoms to attain 8 electrons in the outermost shell in order to attain stability. It means that the atom will attain 8 electrons in its outermost shell. And the next rule is the duplet rule. The tendency of atom to attain 2 electrons in the valence shell in order to attain stability. Octet rule, atom will attain 8 electron in the valence shell in the outermost shell, and duplet rule, the atom will attain 2 electrons in its valence shell. Now let us discuss the examples. The first example that I am going to discuss with you is of oxygen molecule. When we write the electronic configuration of oxygen, we get to know that in the first shell we have 2 electrons and in the second we have 6 electrons, as it does not participate in the bonding. We draw only the valence shell of both the oxygens. Now, this is having 6 electrons in its valence shell. We will represent one oxygen's electrons with dots and the other with cross for our own convenience. Now, according to the octet rule, an atom needs 8 electrons to complete its outermost shell and to attain stability. How many electrons this oxygen and this oxygen needs? They both need 2 electrons. Now what will happen over here? How many electrons this oxygen is having now? 1, 2, 3, 4, 5, 6, 7, 8. And similar goes for this one. Have a look. 1, 2, 3, 4, 5, 6, 7, 8. Now they both are having 8 electrons. They both shared their electrons and attained stability. Now I am taking the example of fluorine. What is happening in this case? Each fluorine is having 7 electrons in its valence shell. I represented one with dots and the other with cross. Now how I know that this fluorine is having 7 electrons in its valence shell without writing its electronic configuration? If you want to know, then watch till end and I will tell you the trick at the end. Now how many electrons each fluorine need to complete its outermost shell? It is having 7 electrons. It needs only 1 electron to get the noble gas electronic configuration. And similarly, this fluorine also needs only 1 electron to attain stability and get the noble gas electronic configuration. They both will share 1 electron and they will attain the noble gas electronic configuration. Now how many electrons this fluorine is having? 1, 2, 3, 4, 5, 6, 7, 8. And similarly, how many electrons this fluorine is having? 1, 2, 3, 4, 5, 6, 7, 8. It means that both the fluorine are now stable. Now coming towards the examples for the duplet rule, first I have write the noble gas helium which has only 2 electrons. Now according to the duplet rule, the atom attains 2 electrons in its valence shell. Now helium has already 2 electrons. Hydrogen is having 1 electron. When it will combine with another hydrogen, they both will share their 1 electron. Both the hydrogens shared their electrons and completed their valence shell. Now, the next concept that I am going to discuss with you is the orbital concept. But let me first tell you about how I knew that fluorine is having 7 valence electrons. Have a look on the first group. All the atoms are having only 1 valence electron. In the second group, all the atoms are having only 2 electrons. Look, fluorine is present in group 7 of the periodic table, so it is having 7 valence electrons. It means that elements present in a particular group will have the same number of valence electron as its group number. The next concept that we are going to study is the orbital concept. Orbital concept tells us that the atomic orbitals overlap over each other to form the molecular orbitals. Let us understand this concept. Here we have two s orbitals. Remember that the s orbitals are spherical in shape. When these orbitals overlap over each other, they form molecular orbital. This kind of overlapping is known as head-to-head overlapping, and the bond formed in this case will be sigma bond. Here we are taking the s orbital and now this one is p orbital. When we will rotate this p orbital, it will overlap in this way with the s orbital. This type of overlapping is also known as head-to-head overlapping, and the bond formed in this case is also known as sigma bond. Now coming towards the 2p orbitals. When we will be having 2p orbitals, these p orbitals will overlap in this way. Such kind of overlapping is known as side-wise overlapping, and the bond formed in this case will be pi bond. Let us take the example for the sigma bond formation of ss orbital. When we write the electronic configuration of hydrogen, we know that it is 1s1. Means that the electron is present in the s orbital, and when these atomic orbitals overlap, they form a bond in this way. Now, this one line, this one bond is known as sigma bond. So, it is similar to this case. Consider it as one hydrogen and this second hydrogen. They both are overlapping, and this overlapping is head-to-head overlapping, and the bond formed is sigma bond. For the pi-pi overlapping, let us take the example of oxygen. When we draw the structure for oxygen, we get to know that it has one sigma bond and one pi bond. We will study in detail the head-to-head overlapping and side-wise overlapping in detail in the valence bond theory. If you understood the topic, then don't forget to like, comment, share and subscribe my channel. And if you have any question, then let me know in the comments below.